Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Hi, I'm Sharon Todd, and welcome to the HFE Hub. Today, my special guest is Daisy Veitch, who is an expert in applied anthropometry and the fit of wearable items and body shape and size data. She is the owner of the US design patent and has registered designs in Australia, Europe, the US and the European community. She is an experienced anthropometrist and directed the Australian National Size and Shape Survey in 2002. She has a background in technical aspects of garment construction and is the winner of numerous awards, including the Designer Award and Queen Elizabeth II Silver Jubilee Award for Young Australians. So Daisy, thank you so much for joining us all the way from Ohio, I believe. Lovely to have you on board with us on the HFE Hub today. You are very well known amongst many of our membership, but I'm quite sure there's plenty of people who don't know you. So let's talk about your background and your work.
Sure. So I came to the current position, which is Director of Anthropometry at Anthrotech, through a route that I can 100% guarantee no career guidance counsellor would ever have recommended. So I started off university and I did maths and economics. And I thought I would take a year off to go and do fashion design because it couldn't be that hard to sew your own clothes, right? And when I went to fashion design college, I got bitten by this bug, which was the patternmaking bug, which essentially translates the 3D human shape into a two-dimensional pattern that then gets cut out of fabric and then sewn up into 3D and put back onto the body. And it didn't work consistently. And I thought there must be a way to solve this. Because I came from a maths background, I thought, it's just a question of the algorithms or I'll be able to figure it out. But it turned out that the reason that I couldn't solve it was not because there was not an answer, but it's because there was too many solutions and I had multiple things that would all come up with a solution and I didn't know which one was correct. And I ended up in college just being completely fascinated by this problem. And at the end of my college, I won a design award, which was the Australian Wool Corporation Young Designer Award in 1987. And that sent me to Europe for 4 months. And I visited all the fashion capitals and it was absolutely marvellous. And I got this overview of how the international industry worked in a way that was magical because you could never, that's exactly the time that you need it, right at the beginning of your career when you're starting out. If you've got some kind of huge global experience that gives you an overview of what's happening in the industry, you couldn't get better than that. And that's what I got, which was amazing. And I came back to Australia and I just thought, wow, it's not just a problem that we have in Australia, it's a problem internationally. And I ended up working in a technical role in garment construction and as a pattern and product design engineer for a number of years. And I learned an enormous amount about how to solve that very first question that I had burning in my heart when I went to fashion design college. I ended up figuring out ways to solve that, but it was really only after years and years of experience. And I realised that we were missing who is average, like what's the body measurements? And it wasn't just the fashion industry that had a problem. It was many industries that were grappling the same types of issues, not just who's average or who's the most commonly occurring body shape, because that's a much better way to think about it, but it's who are the extremes and what's the safety involved in terms of a design. And I was very, very fortunate enough to be able to retrain at the end of the 1990s in anthropometry, and then I ended up being involved in a national size and shape survey, and I've been involved in the field ever since, and I've done all kinds of fascinating things, including making mannequins.
We need to talk about some of those fascinating things. So we probably don't have all day to talk about all of them, sadly, but maybe you could tell me what you're working on at the moment.
So right at the moment, we have a contract with the US Marine Corps. The contract is to measure a number of males and females and have a look at the application of the measurements into the various products that the Marines wear. So it used to be that people wore clothing and then they used products. So you would sit in a car and a car might be a workspace. But these days, people are wearing products and they've got some kind of a mobile workspace on them, if you like. So, for example, a vest that the police wear, that is a workspace for them, and they have all their equipment stacked on it and around their duty belt. So the interaction of all of the equipment that people wear and they are required to wear in their workplace is much more complex. And we're having a look at the fit of the primary objects and also the interaction of how they interact, not only when the person's standing still, but when they have to perform certain tasks as required by their job. And every single measurement that we're taking is related to some kind of design problem, either looking at an existing design or it can be used in the future for to write a specification to solve a design issue or to improve the fit for a group of people and to make sure that it does fit the wide range, because there are more and more people being recruited from different backgrounds. It used to be that people were recruited to armed forces and they had to be a certain age, they had to be a certain weight, so on and so forth. And these days, people are having more trouble hitting their recruiting requirements, and they're trying to broaden out their recruiting in terms of all kinds of things. So we need to fit all those people.
Can you explain maybe in a bit more detail how body size and shape actually influences how people experience the design?
Yes, I can. I can give a really good example, if you like, about an amusement park design. So in this particular case, there had been an accident and somebody had fallen out of a ride. And the question was brought to me, was that connected to the person's body size and shape, or was it some kind of other factor? And I was able to have a look at the information that I was given, which was some body measurements of the person, and I was able to find a proxy for that person. By that, I mean, I looked in a scan database of more than 4,000 people and found somebody that matched up this person for their body measurements. So I had a full 3D scan of the person seated, and then I was able to place them in the ride. And I also had a photograph of the person just before they fell out. So I was able to overlay the photograph of them and how they were sitting in the chair. I was able to get a scan of the chair, then a scan body, and then overlay them according to the photograph. And you could see really, really clearly that the answer was yes. Body shape had an important influence in this. And in this particular case, the person was one of large BMI. And they said to me, does that mean that we can exclude some people with large BMIs? And I was able to do an analysis on that. And it turns out that the BMI so I was able to do an analysis of the BMI, and it turns out that there was a lot of tall individuals, males, who fitted in the ride absolutely perfectly. And what had caused the problem here was a combination of the person's hip width and their abdominal depth. So you can imagine someone with wide hips and their stomach protruding. And if you think of, say, a body type that would match that, it might be a pregnant female. So this was disproportionately biased against women with large hips, actually. So it turns out it wasn't just some kind of random accident and you could exclude large BMI people. It's a particular body shape. And that in anthropometry is one of the golden findings, if you like. So it's not just randomly that a particular person is not safe. It's that a particular group of people are unfairly excluded from a design. And that's a clear indication that the design needs to be broadened out to allow more human variation. Because along with this wide hip, I thought, maybe it's just people who are very large, but I found somebody that was 60 kilograms, which I think the average in Australia for women, weight of women is around 72 kilos. So she was, a size 10, except she wasn't a size 10 because her hips were really, really broad. And she was definitely under 25 for her BMI, and yet she wouldn't have been able to safely ride in there. It's a women's thing.
Are you telling me that some designs discriminate, or does it actually make it worse for the entire group?
Some designs discriminate against a group. Obviously, that is absolutely the last thing intended from the manufacturer's perspective, and they're completely not aware of it. And sometimes that's because the testing or the quality assurance processes that they have put forward to test their product did not include the variation that they were expecting to see. I'll give you a really good example. So often people talk about the 5th percentile female and the 95th percentile male. So for those of you who aren't familiar with sort of this human factors talk, a percentile is if you lined 100 people up and someone was 5th percentile, there'd be 4 people that were smaller in that measurement and 95 people that were bigger in that particular measurement. So the thinking is that women are just small guys. And so if you take the 5th percentile female and the 95th percentile male and design for those, you'll fit everybody in between. But it turns out it's not as simple as that, because for certain designs, it's combinations of body measurements that are important. So, for example, in a seat where, say, you're restrained, so maybe a car seat, and you have to reach pedals and you're driving, so you've got the wheel. Say you've got really short legs. So straight away you're moving your seat forward, you're adjusting it down so that you could reach the pedals. And when you've got 5th percentile female, they're tiny in height and they're tiny in weight, and they've got skinny little tummy and skinny little thighs. But most people are kind of average in weight. So if you've got someone that's 5th percentile for height and average in weight, that's going to be a pretty common combination, right? And when they try and move up, if the steering wheel then hits their stomach or it hits their thighs when they move into that situation, then you've got a problem. And so it's these combinations of body measurements that turn out to be excluding for particular groups of people. And a lot of designers understand that. And sometimes they understand from bitter experience. So they've already gone through the design process. It's already gone wrong, like an accident or a group of customers that didn't fit. And then they've gone back and they've fixed the problem. But that is so expensive doing that. It's so much better to be able to predict and have a look in advance and sort of get in at the design stage to see if you can fix any of those potential problems before they occur. And that's what my job does. Anthropometry is basically applied, or the goal is to apply it to design, to check that design and make sure that that design is performing according to its intended purpose and it's fitting the group of people that the designer was anticipating they were going to fit. It checks all that kind of stuff.
Let's go back to the military vest, police vest. Mm-hmm. My brain always goes to adjustability. So let's talk about how you improve the design.
So, for example, if we were looking at something like a police vest, we know that from previous work that people of a certain chest circumference, say 100, That's a really, really common chest circumference. That person might be a short person or they might be a tall person. So it's no guarantee that just because their chest measurement is in the middle that they're going to be in the middle for height. And particularly if they're working in the military or police and they're working out, they might be a bit sort of stronger or bigger in the upper torso. And so that person might be shorter. So in terms of adjustability, you have to have a long length, a medium length, and a short length. Because why do you have to have short? Well, what's the goal of the vest? The goal of the vest is to stop any kind of ballistic missile. So if somebody's shooting you, it's going to stop a bullet and save your life. That's the goal. So the idea is that vest would then cover all of your internal organs, at least the ones that are considered really important, like your heart and things like that. So if it's too small, then it doesn't have sufficient coverage. And if it's too big, you can't do things like sit down, because when you sit down, the vest comes up and hits you in the throat. So straight up. So somehow you have to have that middle ground. And if you're thinking about police officers, they're in and out of a vehicle all the time. And that's an example where a vehicle is a workspace for them. And so the vest absolutely has to work when they're seated in the vehicle, as well as when they're standing and running and handling a weapon and doing all the things that they're going to do. So how does that relate to body measurements? It relates to body measurements in that you've got to have length adjustment. And if it is something like ballistic material, you can't just go cut it with a pair of scissors to make it shorter. It doesn't quite work that way. Yeah, it has to come in the right size. And that means that the correct sizes need to be ordered. So law enforcement, their job is to enforce the law. Their job is not to be experts on clothing. And yet they have a multi-million-dollar budget and they're expected to spend that budget in the best way. So they're the types of people that really need support because they're a procurement. They end up being a procurement agent buying something that they're not expert in, and they don't necessarily have the in-house expertise to make those decisions. That's where we can help in terms of the adjustability. So you have to have the right amount of sizes, the right coverage in the sizes, and then once that plate gets into a vest, there will be Velcro over the shoulders and Velcro around the side. So there has to be the right kind of adjustability to make the vest so that it doesn't, for example, flop around and allow the bullet to go on the inside. And yet it's not so tight that they can't breathe when they're running, for example.
Okay. How about controls then for something like the amusement park? Because it's a bit difficult to adjust steel and other products.
Yeah. So things need to happen at the design right at the beginning. So the design needs to check. I guess you could do it two ways, check things. You could either check it by waiting until there's an accident and then go, oops, that was a mistake and we should exclude that group of people. Or you would have some kind of good prediction method where you could say who was safe to ride. Now, in an amusement park, they already do that. So they say, you can't ride the ride unless you're taller than 1.10 meters, for example, or the old 4 foot in the US. So they already know that really small people, they can fall out. And so they're trying to just exclude everybody based on height. But at the other end, they're not sure how to exclude. And certainly there's no diplomatic way to exclude people, say, that have large hip girth. And particularly if it's borderline and you don't know whether they're going to be safe or unsafe. So you'd have to do something like, and many people I'm sure have already done this, you'd have to have it so that there was a warning on the restraint system, and the restraint system could not be locked in place if the person couldn't safely ride. And so you could basically sit the person in the seat, say, it's not safe, we can't get the restraint locked to you properly, I'm terribly sorry, could you have, here's a refund.
Yes, I can imagine that would be extremely difficult, but that makes perfect sense, doesn't it?
And of course, if there was a really good method for testing who really was safe to ride and who wasn't safe to ride, could you make it 1.8 meters or 1.5 meters instead of 1.10 meters? Because that extra 5 centimetres, that could get you extra revenue from just a slightly smaller person. So, of course, from the manufacturing or from the operator's perspective, they want to fit the maximum number of people that they can in the ride. They don't want to be saying no to people. But obviously, they completely don't want an accident, and they have very vested interest in only operating a really safe ride. So it's kind of a win-win if you could get a really good testing method. And and I've been talking to a few people about that.
There's a lot of things that flow into that, and you talk about the warning, and I'm just thinking how important that would be, because let's face it, on these rides, these people have often queued for, it could be hours, depending on where this ride is. And by the time they get there, if they get turned away, I imagine they're not going to be overly happy about it. So it would be great if there was some way of checking that at the beginning of the queue. Has that been thought about?
Maybe, and I'll tell you how the Air Force solve that problem, because the Air Force obviously have seats with limited adjustability. They either have to have ballistic protection underneath the seat, or if it's say an ejection seat, then it can't really be adjusted. So the person has to fit the seat. One of the main things that happens during an ejection is you can imagine that the person's sitting on this pretty hard seat, and then suddenly, boof, it's like being punched in the butt, and they shoot out the canopy. And as they shoot out, their buttock knee length, which is how long your legs are when you're sitting, that can't be too long, because if that hits the dashboard on the way out, you have a double amputation. Yeah, ain't pretty. So they really need to get it right in terms of seating. And what they do is they have measurements of people who absolutely fit and people who absolutely don't fit. And then they have a grey area in between, and they have a mock-up seat, and then they put the person in the mock-up seat and they say, hey, you can safely fly this, like a train, like a fighter, or you could fly a helicopter, but you can't fly, a trainer or something like this. That's obviously a terrible scenario, which happened actually in the US Air Force, is that we had some people that couldn't safely go through the trainer who would have been safe to fly the air craft itself. So that's a terrible situation where you're restricted via your training vehicle of who you recruit. But anyway, back to the amusement ride, you could have a seat in which people could just go and sit while they're waiting in the queue to see if they could safely lock in or not. And if they were in doubt, if you're in doubt, just queue up and sit in that seat. If you can't lock it down, then you can't ride, and that would weed them out. I don't know how practical that is, but it would be a foolproof way of doing it.
Personally, I always think of chairlifts, ski chairlifts, and you've got a small kid, and children start skiing at 3 and 4, and chairlifts are only built for adults and their skis and all their stuff. And it's terrifying to go up the side of a mountain, literally holding on to this weeny small child. Anyway, just a personal problem. But yes, I don't suppose you have any quick ideas on how we could solve the ski lift problem for me.
Well, you could definitely think about putting a central bar between the legs so that if they slid forward, they would hit the bar. The problem with that is that if somebody went skiing, say, in an evening frock, that could be a little bit of an issue. But I don't know that many people ski in an evening frock. I think probably with a ski suit, you're safe.
Yes, a bit drafty in the evening frock. So, are there other ways that the design can fail associated with body size and shape that we haven't talked about?
So in the fashion industry, in some ways it doesn't matter if the design fails, because it matters to the company if it is the company's core consumer group that it's failing for. It doesn't matter if it's not a core size for them. So, for example, if a company specialises in clothing for really small people and large people can't fit, everybody knows that and they don't shop in that shop. Or the other way around, if it's a large fit size shop small people know that they're not going to be able to shop there. So there's times that it doesn't really matter. Then there would be other times when people expect to get some kind of modification. So if you were disabled and for some reason you had like an amputated, both of your legs were amputated, you might expect to have hand controls on the vehicle. So you could specially modify the vehicle. The problem is when it's a core group of customers for that particular product and they're not being fit. They expect to fit and they don't fit. Or they have to fit in the case of a uniform and they're forced into a size and there is no size for them, then it's the issue.
Absolutely. And your reference to military, obviously I'm bouncing around in my head between seating and clothing, but you're going to have people that have spent a lot of time learning their craft, very skilled professionals, and suddenly they don't fit into the protective equipment that they need to wear.
Yeah, and I mean, a hospital is a good example of that. So talking of highly skilled people, you have a surgeon who's trying to go use some kind of virtual reality headset. A lot of them wear glasses and they're trying to accommodate the glasses inside of the headset. It's a workspace for them and they're having to work on an operation like a remote operation or whatever. And they have to operate in that space for, say, 4 hours or 5 hours. Comfort is a factor. You can't have the person sort of squinting up and down. Yeah, so there are definitely environments that are very specialised and specific, especially around the head. The head's a really big hot topic at the moment with all of the virtual reality headsets that are coming in. And head measurements are not necessarily sufficient. And interestingly enough, head measurements is one area in which there are racial differences. Normally, for a lot of designs, racial differences don't really impact. It can for a size. So you might be making sizes in Vietnam and they might be really small, and then making sizes in Tonga and they might be really large. But essentially, if you fit one person, it's going to fit a group of people, and it will often the same basic shape. If it's, say, designed for females, it will fit a group of females, no matter what race they are. But when it comes to the head, and particularly eyewear, glasses, sunglasses, or helmet fit, that can be different.
So we need to be moulding some of these specifically for people. I'm thinking of the surgeon. So the surgeon, obviously, this is, life and death critical work. They would need to have a specially moulded fit, wouldn't they?
Yeah, so there's been some really interesting work done in terms of moulded fit. So IBV, which is the Institute of Biomechanics in Valencia, they're doing some interesting work on custom moulded fit of shoes, inserts of shoes. And what they found, they worked with a company who was basically trying to do individual fit for a whole group of people. And they found that they could group people into like 5 different shapes, something like that. And so if they just had these 5 different shapes in a particular size, it was able to fit 99% of the population. So sometimes you've got an individual fit in your mind, but it turns out that you don't exactly need an individual fit. Another example is spacesuits. There's been a problem with spacesuit sizing. They only have a certain number of small, medium, and larges, and they've had to juggle around which astronauts go out together because they can't have too many people the same size to go into the spacesuits when they go out. That's a case of changing the person to fit the equipment instead of what you were suggesting, which is changing the equipment to fit the person. So it's happening both ways.
And there's so much more wearable technology as well. I've done a podcast recently with Chris Reed at Boeing talking about exoskeletons and the fact that anthropometrics makes a huge difference to that. This isn't overly cost effective, though, is it? If you think about the fact that there are so many individual shapes and sizes, how do we make a design work for more than one person?
Yeah, so that's the question that manufacturers are asking the whole time, because of course they don't want to manufacture 1,000 different sizes. They'd like to manufacture one size for 1,000 people. Yeah. So essentially what you need to do is you need to have a look at each individual design and understand what is a fit and what is a no fit. So that's called a concept of fit. So you get the concept of fit going, and then you start putting people in, and you have to get fit passes and fit fails. And then once you've got the fit passes, you have what's known as the range of fit inside of a size. So that tells you how broad a range of body measurements will fit inside of one size. A good example of that is, say you were fitting a pant, and the range of fit in the waist for it was, say, 40 millimeters, 4 centimeters. And then they said, well, that's not really good enough. We need a broader range of fit. Can you come up with a broader range of fit that'll fit more people? And then the design team come back and they say, well, if you give it a half elastic waist or a quarter elastic waist, or at least if you elasticize the front, so when the person sits down, it's not digging into the front and the rib cage, then that will fit a range of, say, 60 millimeters or 80 millimeters per size instead of 40. And then suddenly that broadens it out, because that means that people with differential measurements between their waist and their hip will fit in that pant better. So there's a whole lot of solutions depending on what the product is, what the treatments can be, what the options are, what the existing range of fit is to start with, what the goal is for the new range of fit. And if you understand what's happening in terms of the design, the body measurements, and the population that you're going to fit, and you put all of those three together, then you can come up with options, and senior management can reject them if they want. So senior management can say, yes, well, that's all very well about the waist, but we don't do any of our garments with an elastic waist. We don't like that styling. You go, okay, that's fine. I put it forward as an option and you rejected it. No worries. And they just continue with whatever the sales are. So essentially, there's a lot of factors that go into that question. It's huge.
Okay, so let's make it a little bit more finite. Let's talk about the surgeon with the headset. How can we modify that design?
So, for example, you might go, well, we'll have a more softly molded face shape so that it deforms around the glasses, for example. And then you might have a hard section, which was just a forehead stabilizing, so that when they get tired, they've got something to lean on. Yeah, and then the rest of the fit is really soft, considering that you don't need to, like a scuba diving mask, you don't need a perfect fit on the scuba diving mask. You do need a perfect fit because you don't want water coming in. But the surgeon doesn't necessarily need that perfect fit. So you'd have to have a look at, so here, straight away, the definition of what's a perfect fit is different. Both of those things get mounted on the face. However, the requirement of what the surgeon is meant to do and what the scuba diver needs are quite different. So again, that comes down to the concept of fit. What's considered a fit and what isn't considered a fit. And in terms of that understanding of what the fit is for the surgeon, you'll get feedback pretty much quite straight away, I would say. The surgeon will say, this is acceptable, that's not acceptable. And you can incorporate that into the concept of fit. And then you have a look at the options, all of the options for increasing the range of fit.
I want to come back, I think, to your testing, the test that you did with the avatar and the work on the amusement park. Can you maybe give us a little bit more depth into sort of how you did that? I mean, you've talked obviously a little bit about how you've done it, but I'm interested. I'm sure there's more to it.
Yeah, so the big surprise for us, and this was the reason, one of the reasons why I was asked to assist on it, is that the regular human factors people had gotten stuck. So they'd gone through the regular testing, so you have a look at all of the body measurements and to see whether there was anything particularly unusual, and then had a look at that person those individual body measurements. But as soon as you've got a 3D shape, this was the big breakthrough. When you have a 3D shape, inside of a 3D shape, it became immediately apparent that the large hip of the person was stopping them from sitting down into the seat. They were seated into a fiberglass shell, and they weren't able to sit in the fiberglass shell. So instead of their bottom and their thighs being in contact with the base of the seat, there was an air gap, a large air gap under there. And so what it meant was when you were looking at individual body measurements, they all looked like they fitted, but the body measurements were displaced from seated right into the seat to sitting maybe 15 centimetres above the seat, because the person's hips didn't fit in. And it became completely clear in 3D that basically the person was sitting on top of the seat instead of in the seat. And that meant that the restraint that was meant to sit right in, basically underneath the stomach and on the thighs to stop the person from sliding out, instead of it sitting in the location that it was supposed to sit in, you can imagine now the thighs are really up high. And so the restraint had stopped and wasn't coming into the correct position on the person. And there was a massive gap there, and the person just slid out. So it was the combination of body measurements that only became apparent when you looked at the 3D avatar inside of the shape of the seat, that you could have done 1D analysis till that's one dimensions, analysis until the cows came home, but you wouldn't have seen the relationship. And that's the beauty of some of the new technology that's coming in now, which is the visualization of 3D. So maybe 3D is not the best to take measurements from and to extract measurements from, but it's absolutely excellent for visualizing what the actual problem is inside of the fit. And then you can see which measurements are relevant and what's really happening and where the person is fitting and they're not fitting in terms of the design. And you can completely recreate what went wrong.
I'm fascinated. I guess that leads to a really great question, which is probably what's next for you, given that these projects are highbrow and interesting and lots of in-depth stuff. What's next for you?
So we've just finished writing a book. I've written it with my co-authors, Kathleen Robinette, Sandra Alamany, who works for IBV in Spain, and Karen Bredenkamp. And our book is really about product fit and sizing. And we're talking about sustainable product evaluation, engineering, and design. And why is it sustainable? It's sustainable because if you can get the design right in the beginning, it doesn't cost you any more to do that. It's an early intervention, and instead of producing a product that ends up in landfill, so much of us have heard so much apparel product is ending up in landfill brand new. Instead of producing a product that's basically trash before it even leaves the factory, you're producing a good product, and then that product can be used for its intended purpose for many years to come. And that's really where the sustainability of good design comes in. And anthropometry is only one little part in that puzzle. It's and that's what our book is about. And it breaks it down into how you can apply anthropometry in the design loop, which is what I was just talking about then. How do you apply it in the sizing loop to make sure that you really are fitting the customers that you thought you were? And what are the type of outputs that you can get for your company in terms of fit standard and saving money and producing a product that can be used for years to come? And also sustainable tariffs, which is the breakdown of how many of which size, because we've all been in a situation where you've gone into the shop and your size is sold out. And there was only sizes that nobody wanted left. We don't really want that. We want all of the sizes to be there for as evenly for all of the product. That's called the tariff. So that can all happen out of this type of design testing and the application of anthropometry. So anthropometry, if you like, is only this tiny little puzzle piece. It's an extremely important puzzle piece. but it doesn't stand by itself necessarily. So what's next? We want to do some teaching courses around the book. The book hopefully will come out in August, and we want to continue with the work that we're doing here at Anthrotech and help showing really practical, simple examples of how to apply anthropometry in relation to a product to get better outcomes and more sustainable future. I guess that's why I'm here.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.